Springboard. The aptly named Springboard might be the company that helps you take a big jump in your career. They're not just an online learning system where you get access to a curriculum and some quizzes and examples and things like that. One of the things that's special about Springboard is you get assigned a one-on-one mentor. They're going to meet just with you on a weekly basis. How often have you struggled to understand something only to have a friend tell you in a very simple way how to do it? Take a look at all the mentors available on the Springboard website. There's people from all sorts of different backgrounds to connect with. You can find the mentor who's right for you. They've got financing available, and they make a guarantee on getting you a job. Check out their site for the specifics on that, but Springboard's really serious about helping people move ahead. Their placement rates have been sky high so far, and in addition to your mentor, you'll have career coaches helping you figure out how to navigate the job market and find a place that's right for you. I'm going to give you a bit.ly link, so we're only going to say it once, so grab a pen or be quick with your thumbs to type this into your phone. Pause if you need it. Head over to bit.ly, bit.ly/data science learn, all one word, all lowercase. Data science learn. People finish the program by doing a capstone. We've got a special offer here for the first 2 people who make it through to their capstone. I'm going to offer a personal hour of my time to sit with you, have you present your capstone to me if you'd like. I'll give you feedback and any advice. We can spend the hour however you'd like, but I'd love to see what your capstones turn out to be. Springboard alums have gone on to work at Uber, LinkedIn, Facebook, Amazon, and many other places. Don't forget that job guarantee I mentioned. To learn more about Springboard, visit that bit.ly link I mentioned, which will be in the show notes.
Data Skeptic is the official podcast of dataskeptic.com, bringing you stories, interviews, and mini episodes on topics in data science, machine learning, statistics, and artificial intelligence.
So Linda, today on Data Skeptic, we've got one of the people involved in something called Project Common Voice. They're building out a system that's going to make available lots of different audio samples of people talking and also the text of what they said that'll help researchers build better speech recognition tools. Now, I want to ask you something. When you were a kid, was there any speech recognition in any of your toys or devices or anything?
No.
So what changed within your lifetime and when did it change?
Well, I imagine the algorithms for understanding our speech have gotten better. I actually think back in my day there was something where you could speak into a microphone and try and have it type.
It didn't work
but
at all.
We didn't use it because we had heard it had gotten bad reviews.
Yeah.
So I was pretty good at typing. We had taken Mavis Beacon. So.
Oh yeah, you did Mavis Beacon.
Yep.
I remember.
So I'm very good adept typer. No bug splats on the window shield.
What does that mean?
Well, there's a game where it's like you're driving a car and every time you have a typo, it splatters a bug on the windshield.
I'm sorry, you took a lot for granted assuming we would know that, but okay.
Yeah, then like if you could type faster, it's like a car driving and your speed goes up.
Oh, that's cool. I like that.
So it's like you're racing if you could type faster and it's like a game. That was the best part of Mavis Beacon. Everything else is like not as fun.
So speech recognition, though, obviously everyone's going to still need to type. That's going to be a common input, but voice as an input is becoming absolutely prolific, right? I see you doing it with your phone quite a bit.
Google Voice. Yeah, Sometimes it freezes, though.
Yeah. Well, that's a longer discussion about why that is. The point is, you sort of said it correctly. You were like, I guess the algorithms have gotten better. That's essentially true. The algorithms have sort of gotten better. But more than that, the people who are successful with this stuff, they have massive amounts of training data and computational power to build these models with deep learning that are capable of recognizing speech.
So is that why it's gotten better? Because they have more data?
Well, I would say, there's like 20 good reasons why it's gotten better. More data and the capacity to process more data are two of the big ones.
Oh, capacity. Okay.
Can you build a model on 10,000 hours of speech text? That's unheard of in the 90s, but today it's practical. Although I must say, it's something that only large companies can really do right now. Yes, but things like Project Common Voice are turning that around where everyone can do some speech recognition stuff.
Where is Common Voice based?
They're part of Mozilla.
Oh.
Yeah. So here's something that's interesting to me. The speech recognition you see in the market today is all proprietary. Now, you can get it through APIs. People will expose it, but you can't have their actual algorithm, nor can you improve it. So, for certain languages, we might be running behind. It works really well in English. I can testify to that. I don't know and I bet it works well in Chinese because Baidu is one of the big companies who made a lot of progress in speech recognition.
You mean Mandarin?
Yeah, what did I say?
You said Chinese.
Oh, yeah, Mandarin. Well, what's the other language that a lot of Chinese people speak? Cantonese?
Oh, yeah, there's Cantonese, Mandarin, and I don't know the others.
Probably more, yeah. So I would bet those probably work well, but something like Tagalog or I don't know, some more exotic language, I bet the speech recognition systems don't do well. Do you know anything about tonal languages?
Well, Vietnamese is tonal. I can't really speak it well enough to even try using it.
So what I like about Project Common Voice is it kind of democratizes this. It makes that data set available to lots of researchers. So if maybe you were someone who wanted to build a good technology that would interpret Vietnamese as a language, if maybe the commercial offerings are running behind, you have a decent opportunity to work on that, given some of both the models they've released and this code base that they're building up. Now, the code base is in lots of languages. Maybe it doesn't have a lot of Vietnamese in it, but you could basically train the initial model and then maybe do some transfer learning. So regardless, I think this is a great tool that I'm glad to see is becoming open source. Thanks to things like this, in a very short time, we'll just consider speech recognition to be like a utility. It'll just be available for free in software development.
Amazing.
Yeah, it really is. It's a very transformative thing that's happened in our lifetimes.
It's like finally, slowly happening.
Yeah, right. So enough of that. Let's get into the interview and learn a little bit more about what Project Common Voice is doing.
Let's hear it.
Andre Natal is a software engineer at Mozilla with over 17 years of experience in the development, architecture, and management of software projects. He has extensive experience in software engineering, having worked in various industries such as internet, legal, government, media, Wall Street, microelectronics, and mobile. Andre is passionate about speech and audio technologies and has deployed a large number of award-winning applications across different platforms, including mobile, IVR, and IoT. He is particularly interested in building conversational agents, speech-enabled devices, and voice-controlled VR and AR experiences. Andre holds a bachelor's degree in information systems from the Universidade Anhembi Morumbi in São Paulo, Brazil. Andre, welcome to Data Skeptic.
So, yeah, I'm glad to be here. Thanks for inviting me.
To begin with, I'd love to know a little bit about the project you've been working on.
Mozilla right now, as you all know, so Mozilla is a non-profit, open source, company. Everything we develop, we develop a bunch of things besides Firefox. And right now, I'm part of the speech recognition team. One of the projects that I'm working on, it is the voice fill. It is a text experiment to speech-enable search engines on Firefox, and also Common Voice. It is an initiative to ask our community to donate speech recordings, so we could improve our own speech recognition models, and also give back that data to the community of researchers so they could build their own speech models and etc. Those are the current projects that we're working on, but in the future we have plans to also ship in a speech API. Mozilla is going to have their own speech API, so we could both use web speech API in Firefox, but also in a different projects like a node model, and you could use on your own project. So those are our current, speech initiatives inside Mozilla. We also have something called a Deep Speech. It is a research project that we are building our own speech decoder using TensorFlow. We also have a Web of Things gateway. It's going to be an IoT platform that is going to be speech enabled. So yeah, those are our current speech initiatives. Quite a lot for a company like Mozilla.
Yeah, definitely. Very exciting, too. And I think cutting edge voice has been becoming ubiquitous in the last few years, and I see a lot of success in this space. That was one of the things that attracted me to the Project Common Voice, because there are some challenges if maybe I wanted to take on my own speech project. I'm not a big company. Before Common Voice, was there any way an independent researcher could really get involved in any sort of interesting machine learning on speech work?
There is a project called VoxForge. Not sure if you heard about it. Is they try to do the same, but never got much traction. Now is the moment, as you said. As an independent engineer, it's hard to get data, right? So that's our goal. We're gonna both ship data, data collect from Common Voice, but also the models that we build, they are going to be openly available. So not only data itself, we're gonna train the data ourselves and ship the models. So yeah, you also faced that same situation. It was hard. And you need to rely on third-party companies. And for independent developers, it's super hard. You need to either buy, licenses from new ones, from some other third-party companies, or you need to build yourself. So we are here to make that better to help the researchers and applications you spread out. So that's our ultimate goal.
Well, that's a very interesting idea, the concept, well, all of it actually, but especially shipping the model. So I, as a data scientist, might not need to train my own model. I could start with yours, maybe, and that's sufficient for me, or maybe I use it as the basis for transfer learning. What do you mean when you say shipping the model? Am I getting your TensorFlow code and objects?
Yes, exactly. That's the goal. Our TensorFlow, for example, in this deep speech specifically, the code is all there. Code is completely 100% on GitHub. So, but in the future, we're going to also train those models and ship them. We're going to make them available. So you can just download our model and do, as I said, transfer learning and improve the models. We're going to share the checkpoints and just use that from there. But in the case for voice field, we are using Cowdy. Cowdy is a speech toolkit that also uses deep neural nets. We started from a pre-trained model, but we are going to enhance the model and also make the models available for download so we can continue the work. That's unique in the data science world, especially for speech.
Yeah.
That's our goal. So to make it better and contribute back to the community. Mozilla, as you know, right? We are 100% open source. We are made from the public to the public. So that's our goal. Everything we're going to build here is going to be open and available. Everything open.
That's really exciting. I think it's going to open up a lot of opportunities for voice in applications I can't even predict yet, maybe. I'm curious to hear more about how you get the corpus that is Project Common Voice. How do you get all the recordings and make them available?
The data itself, the transcriptions and the corpus of text so users could speak, it is inside our repo. Maybe you could link the link to the repo here. But it's basically github.com/Mozilla/voiceweb. That's the name for Common Voice. I know it can sound weird, but that's the, how we named that before, be named as Common Voice. It's voice-web, actually, the name of the repo. So the corpus is all there. You can just contribute with text, send a pull request with a corpus of text, and then we merge, and that's it. That makes available to the users. But regarding the data, it's basically users, they are just saying the word, the sentence that we ask them to say, and then we store that in our servers. At some point until the end of this year, we're going to make all that data collected available to download for the community. That's the ultimate goal. And also to add other languages as well. Right now we are using only English, but for sure you're going to support Brazilian Portuguese, Spanish, French, Germany. So that's the ultimate goal. That's one of the problems with speech. There's a lot of, not a lot of, but it's possible to get corpus of speech in English already. You can have some lib speech or some other, but for other languages it's really hard. So that's the goal.
Something that's really novel and interesting to me, I didn't even realize I could send you a pull request if I had sentences that I thought somehow were phonetically interesting and not in the corpus. You might accept my pull, and then someone would go out and say the thing I asked them to say, and that would enhance the data set.
100% correct. We have a lot of contributions already like that. People contributing with different sentences. That's the goal.
Oh, that's outstanding, and kind of a neat opportunity for like a linguist too, maybe, to make some contributions.
Exactly.
If I wanted to contribute just my voice, how would I go about doing that?
It is voice.mozilla.org. Just go there.
And the plugin's right in the browser, so someone who wants to, maybe doesn't even know how to code really well, but would be willing to read some sentences, they could be an official open source contributor.
Exactly. No, you don't need to be a coder at all. Just browse to voice.mozilla.org and start reading. You don't even need to contribute to read sentences. If you just want to read, to listen and validate that, you can just do that, because we have both the contributing platform, so people can donate data, but we also have the validating. We need to validate, to do the properly annotation. So you can listen to sentences and just check if it's correct or not. So when we make this data available, we're gonna also give them annotated, right? So you're going to have properly validated data from the community as well. So it's both crowdsourcing to record and also to validate. So both validation and recording are crowdsourced.
Oh, very neat. It would be kind of surprising to me if someone wanted to waste a lot of time and go and just make nonsense recordings, or something like that to sabotage the project. I bet everyone is pretty well intentioned in the recordings they provide.
Almost 100% of the sentences are properly read. They read exactly what you asked for. There's no kind of sabotage, people saying nasty things. Almost 100% are accurate readings of what you asked for. It is awesome. That's really good. Yeah.
Oh, wow. Yeah, I thought you'd at least have some errors just on people fiddling with their equipment or something, but it sounds like, I guess maybe the easiness of the interface I experienced when I gave it a shot. Maybe that just makes it so simple for people to contribute.
Exactly. So we are also, probably we are going to ship a new version, enhance this new current version with some gamification, capabilities. We also have a lot of kids reading that. So it's still an early project. We launched it 1 month ago. They're still going on. So we're going to support more languages. We are getting a lot of contributions, actually. I don't know the exact numbers right now, but I can say it was a big hit.
Since you're so broadly accepting of who can contribute, you're probably getting a wide variance of different types of voices, which is really good. Old, young, male, female, deep, high, all these sorts of things, reflecting the real world. But you're also getting a variety of different technology and background noises and recording equipment of various quality and things like that. That's probably a strength because a machine learning researcher needs a lot of good example cases. But can you talk a little bit about the variance you see in the recordings so far? Is there a big difference in noise quality and things like that?
Yes, we are getting a lot of variety. Microphones, background noises, accents, gender. Oh yes, that's the ultimate goal. You're really right. So we need that when you talk about speech. We need that. We need the noise. We need to generalize a lot of if the noise or not. So yes, you're absolutely right. So we are getting contributions from the whole world.
So I know in the natural language processing world, we noticed that the larger the corpus, the better the models get. I assume there's some similar results here, that the bigger the amount of recordings you get, the more robust the models will become. Do you have any estimates or goals about how much recorded time the project hopes to get?
Yes, we are planning to get 10,000 hours to have a good model, production-ready model. So that's our ultimate goal, 10,000 hours.
Why 10,000?
Because that's what you found in the deep learning literature, the papers that we read elsewhere. And also, I remember Baidu's deep speech, they mentioned 10,000 hours. So we did some experiments with less than that, 2,000, 3,000. We found that we still need more. So we set these goals of 10,000 based on the literature. But let's see, if that keeps going, the much you get, the better, right?
Yeah, absolutely. The more the better, for sure.
Yeah, the more the better, for sure.
Getting back to the variety of different types of voices you get, even within a language, we generally see different accents or different sort of styles of speech. Do you have a sense of how many researchers will end up using this data set? Will they maybe first need to tag things by, this is accent A and accent B? Or does the deep learning approaches to training seem to just kind of normalize across all of those things?
Yes, I believe the deep learning, we don't need to tag accents right now. I think in the future it's going to be useful. And if you want to, build models localized per areas, accents, areas of the country you are serving. But right now we don't have that yet. But I agree with you. That's something that can be, taken account in the future and maybe tag, that level and build models, for specific accents. I'm sure that can get better, but right now, you're not doing that.
Yeah, I've been debating myself whether or not I think it's, obviously it sounds like it's very useful, but I feel like a lot of these deep learning systems would just learn different representations that are somewhat close, and just account for the accent. So it's sort of a neat way that the technology is doing automated feature recognition potentially.
Yes, exactly. You're right. So basically the test that we need, we found that the more variety that you have, the better. If you have, for example, my accent, my Brazilian accent, mixed with American accents, it works well. You know what I mean? I think that's our ultimate goal. We are also asking people, the contributors, to give us their own profile, but it's not mandatory. And that for sure would help, but it's not mandatory. But let's see. That's something that we need to take into account for sure.
And when it comes time that the entire corpus becomes open sourced as well, how do you see that happening? Will there be some zip file that I can download, or what will be the process for me to start researching with it?
Probably, yeah, we're going to have access to the raw data. For sure, we're going to do some polish, try, to get out from the corpus the invalid data. But yeah, something like that. You're going to download a big tarball somewhere with all the data inside, but also after we do some reviewing of the data. But yeah, that's the goal. You're just going to download the raw files, the PCM files with the transcriptions, so you can train your own TensorFlow or Claude or something else. We also have importers. So far, we have this deep speech project that we are running. So we have some importers that are just ready to train LibreSpeech with LibreSpeech data, with feature data. We're going to write an importer to our own common voice, but also for Claude. That's something that I'm going to be working on to create an importer for Cloudy and a recipe. That's how we call it on Cloudy. So you can just download the data and train on your box.
What is that system, Cloudy? I'm not familiar with that.
Yes, Cloudy, it is an open source toolkit to do speech recognition, to create your own speech recognition decoder. It is actually a speech recognition decoder that uses deep neural nets. It is a project, that is sponsored by Johns Hopkins University, if I recall correctly. But yeah, it is an open source speech toolkit, so you can build your own speech service using them. It's really very powerful, and we shipped voice for you using it. Definitely take a look.
Yeah, absolutely, and I'll have a link to that in the show notes as well. Can you tell me a little bit more about deep speech? I understand that you're using the raw audio data as the input. What are the outputs? What is that model trained to recognize or to predict?
Just basically string. After you train and you get your model, you're going to input your own raw data, your PCM file, and I'm going to give you back the string about what was decoded. Basically that. Just input data and output your string.
Raw audio to text then, right?
Yes, raw audio, and give it back the utterance, this transcribe, the description. That's basically just that.
One of the things that's exciting to me about deep speech and the whole openness of the project is that I've noticed some of these systems, and I expect deep speech is one of them, they're very good at everyday conversation. But if you and I maybe had a very technical discussion about pharmaceuticals or something like that, there'll be all these words that aren't necessarily common in a lot of examples. So the translation might not work as good when it comes to jargon, so to speak.
Yes.
But if that's important to me, if I'm going to study text-to-speech for pharmaceuticals, how much does a project like Deep Speech bootstrap that effort?
It's just basically language modeling. There are two different approaches to do speech recognition. There's a bunch of actually hidden Markov models, and then hidden Markov models plus deep neural nets, and then pure deep neural nets, right? We're going to need the representation of those sentences if you're doing pure deep neural nets, right? Because when you're using hidden Markov models plus deep neural nets, you have the phonemes mapped as well. So when you're doing pure end-to-end deep neural nets, you don't have phones at all. But we're going to need the language model covering those sentences that we are trying to target. Like, for example, this example that you mentioned, pharmaceutical, situations. Even though if you have the data, the audio data, the acoustic model trained that, we're going to need the language model as well. That's the difference between, when you're using a hidden Markov model plus deep neural net and then a deep neural net, pure end-to-end recognition system. You still need the language model, right? Even if you're talking about training, if you have a huge, data corpus of speech, a bunch of speech data there, but you need to cover new sentences, you don't need to record that. If you have the phones captured, or in the deep neural net case, if you have the data generalized already, you just need to introduce your new sentences to the language model. That's basically just text. You don't need to record those phrases, those sentences that you want to support. That's the beauty of speech recognition, right? So you just can keep inputting text. For sure, if you have the audio representation of those sentences as well, it's going to be better. But if you have the phones covered, in the case of hidden Markov models plus deep neural nets, it is enough. So that's how we can improve the engine. You can both record and have more sentences added to the model. Recordings, retrain the model, keep adapting with new sentences. But you also can basically just input text to the language model covering those new sentences. You have two different ways to keep the model better, keep the engine better itself.
So I know I appreciate you took the time out of a busy schedule to meet with me today for the interview, and a lot of that centers around some major announcements Mozilla's just had. Can you tell me about some of the exciting new features that went out recently?
So yeah, we have this voice fill web extension that we just shipped. It is basically a test pilot program that we have. Mozilla Firefox will have this test pilot program that is basically an experiment that you install, a web extension that you install on your browser. And it's going to speech enable search engines, basically Google, DuckDuckGo, and Yahoo. You're going to be able to do web search using your voice. And that's the first one. In the future, we're going to be shipping an API as well, web speech API inside the browser, so you can, using JavaScript, speech enable your web page or website. and also as a separate node module, so you could use it on your own projects, that are not browser-wise. So those are the current ones. Also, Common Voice is just ship it, Deep Speech, our research project, and also our Web of Things gateway. You're gonna ship a platform for IoT, so you could also use speech if you want to have your own IoT, your own, speech-enabled speaker at home. You can just use a Raspberry Pi and a microphone, and you're gonna, have your own IoT platform at home. So yeah, those are the current, projects that we have so far.
So I imagine the choice for Node is that it's a great language that'll run in the browser and server side, and you can transpile in many different ways, and so it's very robust. I like the idea of using the Node extension maybe in the back end of my website if I'm doing some offline processing, but also making it available in the future where people who come to my website I can take advantage of that API for them to record in the browser and things like that. With that in mind, can you tell me a little bit about how you connect your TensorFlow model via Node?
Actually, you're talking about online speech recognition, okay? So we're going to have an endpoint, a web service endpoint, that is running inside our own Mozilla's, cloud. And you talk with the specific, we just, push raw PCM, or in this case that we are supporting right now is Opus data. We just push, you do a post with passing this data, this audio data, and I give you back the results. So this node model that you are writing just encapsulates the call to this, this web service. So we have installed in our cloud premises the decoder. In this specific case for voice field is Cloudy, and you communicate with that through this web service using Node. But in the future, and when you ship Deep Speech, it's basically you're going to be able to run offline as well. And also have plans of shipping this service that you're running online, shipping offline. In the future, we're going to have both. We're going to have offline and online. To answer your specific question right now, we are not using TensorFlow yet for voice fill, for this endpoint that we have online. We are still using Cloudy. Basically, we just set up inside our infrastructure Cloudy service with our own models and build an endpoint, a web service endpoint, so you could just connect to it and push your data. Basically that, simple as that. Yeah, very easy, very easy. For this specific implementation for voice fill, we use a pre-trained model from API.ai. They made it available inside Cloudy repo and model, and we started from that, and you're going to increment that model. You're going to, keep improving that model. The point here is everything is available on Mozilla's GitHub. You can go there and have access to 100% open source, everything you are doing.
That's excellent. Yeah. Voice, in my opinion, we're right in the sort of industrial revolution of it. The technology is finally good enough that it works with deep learning, and we're starting to have people figuring out the right use cases. But one thing that's a little unclear to me is, where does that service come from? Is it a part of an operating system? Do I build it myself? And clearly, Common Voice is going to change some of the game there because now it's democratized, it's open, anyone can use it. Is there a vision Mozilla has for how this technology should exist? Is it going to be part of the browser? Where is voice recognition essentially going to be as a service?
So that's a good question. So right now we are using it in the browser, right? Because it's our flagship product. We have that already for us, way easier to just put in the browser. But I agree with you, it's ubiquitous, right? So we're going to have a mobile. We also have smart objects at home. We also have this boom of smart speakers at home. I mean, the new generations, if you see new generations interacting with devices, they are growing up with speech, right? They just expect to work. Doesn't matter where. So I have a clear vision that in the future, every device is going to be speech-enabled. Your TV, your watch, everything, every device, your refrigerators, but that's going to be transparent to the user, right? And also for the user, it doesn't matter if it's online or offline. He just expects that to work. But you need to take privacy in account, so you need to be sure that, you are not, extrapolating users' rights to not, share his data. But they are just expect to work. So we are starting with the browser because it's our flagship project. We have other ideas. We are trying to explore new ideas in the near future. But that's our goal, speech is going to be ubiquitous, and now is the browser. The way you interact with the web is going to change. It's changing, right? So conversational, interfaces, it's pretty clear that's going to be the future, right? You just chat with your agent. And it doesn't matter if it's going to be the browser or a virtual assistant or something in your TV, in your core. So we have some experience, some ideas of delivering a more conversational interface And that starts with speech, right? For sure, you can text. The front end for conversational interface, if you can call like that, it's going to be speech, right? So we're starting with speech, but in the future, for sure, you're going to start adding, conversational interfaces and natural language understanding. So those are the next milestones. But I agree. So it's going to be 100% ubiquitous. The speech and the front door for sure for that.
Excellent. Yeah, I share your vision of the future, and I'm so grateful to see that there's a fully open project that's kind of going to enable just about anybody who wants to work with speech to do so.
Yeah, exactly. That's our goal.
So in terms of timelines, people can obviously make contributions already in the ways we've talked about. I'd encourage everyone to go at least record a few sentences, get your voice represented in the corpus. On top of that, when do you think timeline-wise researchers should start checking the site and looking for how they might benefit from the project?
Okay, for Common Voice, the deadline's the end of this year. Around December, you're going to be sharing data that we captured, that the users donated, For voice field is already there. You just, I encourage everyone to go to testpilot.firefox.com and install voice fill and give a shot. Why not give a try and see how it works? But both are open, just to contribute. And also deep speech. If you are more data scientist, more into deep learning and training models, and you have some GPUs, to spare and test, just go to github.com/mozilla/deepspeech and start to contribute, finding issues. So those are the 3 ones that we have so far.
Excellent. Well, I'll have links to all of those in the show notes. And Andre, give me a heads up later in the year when that launch happens. I'll make an announcement on the show so people can head over and possibly start consuming that.
Absolutely. I'm very happy for you guys having me.
Excellent. Yeah. Well, thank you so much for taking the time to come on and share a little bit about all the exciting projects going on.
Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.